Hey everybody, how are you? Happy Tuesday. Some of you's first streams, that's awesome. Glad that you're here. There's chat. Nice. Hope my brain won't explode from confusion. No, don't worry about that. The whole point is Physics 101. It's going to be really easy to understand, really easy to get started. Hope you're doing good as well. I am. I saw in the chat that you were here last time we streamed. That's awesome. Glad that you decided to come back a second time. The last time was world building. This time it's going to be physics, which, a lot of people have been confused about. So I'm pretty excited for it. I am not the most confident in physics, but while I was working with the physics expert to get this stream up and running and ready for all of you, I was pretty excited and pretty encouraged to see how intuitive and how easy it is to get started. So that's actually a really good segue to introduce who we're going to be talking to today. So he is a product manager on the physics team. And before this, he's been kind of active on dev forums, so you might have seen his handle around. But let's bring him in and he can start talking and we can get this stream started. So get ready, everybody. It is Mobster Lobster.
Hey, Dux, how's it going? Thanks for having me.
Hey, man. Good to see you. So, Mobster Lobster, you want me to call you Mob? You want me to call you Lobster? Is there another name you want me to call you by?
Whatever works for you, man. I'm good with either.
All right, let's do Mob. Perfect. All right, so first things first, to get the stream started, we're talking about physics, right? And a lot of times people say Roblox is a simulation-first engine. What does that mean when we're talking about physics and simulation and studio as an engine? Like, what does that conversation look like?
Yeah, absolutely. Great question. What that really means is that the default on Roblox is that things are simulated. So they have their behavior dictated by physics, rather than prescribed by either animation or the direct manipulation of like the position of every object. And so another way of thinking about this is really just that physics works out of the box and it's its default, and you can always opt out of the default if you choose.
Oh, interesting. Okay. So that sounds nice, but like, why does that, like, why do we care? Like, what is unique about that compared to if it wasn't the case, if it wasn't a simulation physics first engine?
Yeah, great question. It's just cool. That's the only reason. No, I'm just kidding. No, so the reason you should care is because this kind of free out of the box physics enables a lot of free behavior that makes it easier to build on Roblox. So some examples of these sort of free behaviors that you get include gravity, collisions, aerodynamics, materials and material properties. And what this enables is that it enables intuitive building, because what you're really trying to do is build stuff that works the way that it does in the real world.
Got it.
Does that make sense?
Yeah. So, instead of having to think like almost like, oh, well, how am I going to code to make this work? Or what's like the tech that I have to do to make this thing that I see in my head? A lot of it, you can just kind of assume that it's going to work that way because that's how it works in real life. So it's just kind of intuitive. It comes naturally.
Exactly. And on top of that, this kind of physics out of the box, or physics being the default notion within Roblox, enables emergent behavior. And what emergent behavior is that it's when simple rules lead to complex and sometimes unexpected outcomes. So I'll give you a real life example. So, if you've ever been on a frozen lake or anything like that, you know that you start sliding on ice because ice has very low friction.
Oh, yeah, no, we have a GIF for this. Perfect. Yeah, you just slide on ice.
Yeah, we have a GIF on this. Yeah, exactly. So if you pull it up, and I remember the GIF properly, what it shows is that, on Roblox, all you need to do is set the material of the floor to be ice, and then you go run on that floor with your character, and you automatically get this sort of sliding behavior, which is really intuitive and what it's like to be in the real world, which you get out of the box for free. Whereas on other game engines, you might have to kind of build this animation from scratch.
Got it. So like if you weren't on Roblox and you're like, hey, you know what? I want to have a really sick ice level. I want people to slide around and it's going to be hard to navigate. You would have to like code the movement and the animations and like figure out how to do this like intentionally, like painstakingly as part of the flow. But in Roblox, you just take the ice material, slap it down, and all of a sudden you're slipping and sliding without having to code or figure out anything else.
Exactly. It's just a lot easier.
Wow. Well, that's kind of cool. Nice. So you mentioned off a list earlier of all the different things of what the some of those and not emergent behaviors, but the like the free behaviors, the things that come out of the box. The
Hmm.
what are those are what we're talking about on stream today? That list
Yeah,
of
exactly.
okay.
Yep. So we'll be talking about in two sections, really. The first section will be around the free physics. And so this includes gravity and collisions, which is just how do objects behave on the surface of your experience via gravity? And then how do they change when objects interact with each other? They hit each other. Imagine two balls colliding or something like that.
Got it.
We'll be talking about material properties. So we'll give a very high level overview of materials on Roblox and their properties and how you can customize them. And we'll also talk about aerodynamics, which is really exciting. It's currently in a studio beta, but we are hoping to release it soon. And this is the notion of like how do objects behave when they're subject to aerodynamic forces like air resistance or a global wind. And then the second half will be around some of the stuff that you can do to customize the experience via properties and tooling. And we'll walk through an example of our constraint system, specifically an example with one of our mechanical constraints, which is the hinge constraint. So I'm really excited to show you all this stuff.
Got it. So just to make sure that I'm fully tracking, what we see
Mhm.
on screen now, we have the three kind of main chunks. We have gravity and collisions, material properties, and aerodynamics, and that's part of the free physics that you get out of the box from Roblox. Like the ice example, it's there because Roblox is physics first, simulation first. And then after you show us about that, we're gonna go and take a look at some of the tooling that is just how you can customize those built-in lists that we just had.
Exactly. Yeah. How you can customize how objects interact with each other in your experience.
Yeah, which is why we should care. Awesome.
Yep.
I talked about the wrong title, so that's why we should care. But so you can customize the free physics.
Exactly.
Awesome. Okay, so gravity and collisions is first, yeah.
That's right.
Okay, sweet. Let's hop into Studio. Let me swap screens here. All right, your screen is live. We can see what's on your machine.
Wonderful. Awesome. So we're going to go ahead and get started with the most basic stuff out there, which is within the templates, let's just click on base plate and I'll walk you through some of the stuff that you'll see just works out of the box.
Sweet.
So you can see the base plate right now, right?
Yep, good to go.
Cool. So the first thing I want to show you is how gravity and collisions work and how you can kind of customize some of the properties around it. So the first thing I'm going to do here is very simply create or just insert one of these sphere parts that you can think of kind of as a ball.
Okay.
And then we're going to move it up a little. We're just going to move it into the air. Okay.
Okay.
And the next thing to do here is just run the experience and see what happens.
So you say that like we're running the experience. Is there a difference between like running and playing? Like, is there a reason why you're not just like normal playtesting it?
Yeah, that's a great question. Yeah, so here within testing, there's three options. You can either play here, or run. What play does is that it kind of mimics what a user would see if they joined your experience. So they would spawn on this spawn location, wherever you set it to. And that's kind of like the full complete picture of what your experience is like.
Mm-hmm.
Play here is when you still need your character involved, but you just want to start the experience where your camera is currently located. And this is if you're editing some part of your place where your spawn location isn't there, you can use that. And then run, which is what I'm going to do here, is when you don't care about your character being loaded in and you just want it to be really quick to test some other stuff out. So let me show you, and
So in this case,
it'll make
physics.
sense.
Got it. You're just testing the physics.
Yeah, so I'll go ahead and run this and let's see what happens. So if we click run, all right, pretty simple stuff, but let's walk through some of the stuff that we got for free here on Roblox. So I'll stop it and run it one more time. You'll see that automatically this ball has gravity applied to it, which is why it falls down on the ground. It collides with the floor. That's the base plate. It has collisions and it bounced a little. I don't know if you noticed that last part because it is a little subtle. Exactly. And that's where the material properties come in. And we'll talk about that as well. Does that all make sense?
So the part that's unique about the Roblox is that in, other engines, the ball would just hang there in space. Because, you don't have to know that there's gravity, but gravity just works out of the box. It hits the base plate out of the box and it bounces out of the box. You didn't have to do anything. You just literally, it just worked. Which is kind of insane.
Tricks. You saw me just open up a base plate and insert a part and then just press run.
Which is interesting because like, it's funny, like having to deconstruct everything that goes into that, like we already take it for granted. Like if you were to drop a tennis ball right now, everything would happen exactly the same. The ball would fall out of your hand, it would hit the floor, and it would bounce. So when you
Exactly.
see it happen in Roblox, it's not immediately obvious that that's impressive. It's not
Yeah,
immediately obvious that that's unique and that's cool because you see it happen all the time, every day. Um,
100%. And let me tell you, when you're in some of the other game engines where it doesn't happen out of the box, it is noticeable right away. You're like, wait, why didn't this fall? Why didn't this collide? Why didn't this do X? You know?
yeah, perfect, makes sense. All right, I'm tracking.
Cool. All right. So what we're going to do here is talk about some of the properties that you can mess around with within parts to kind of get different behavior. So the first one that we're going to go over is anchoring. So if we click on the ball here, you have two options for anchoring. You can either go here to the ribbon and click anchor. So it's a little hard to tell because it's just a darker gray, but right now it's anchored. Or the second part is here within properties. When you have the part selected, you can turn on and off anchoring. And what anchoring does is, I'm going to read you the definition from the technical docs site just so that it's fully encompassing, but then I'll talk through it. So the anchored property determines whether the part will be immovable by physics. So when enabled, a part will never change position due to gravity, other part collisions, overlapping with other parts, or any other physics-related causes. The way to
So
think about it intuitively is just the object will stay there unless you are directly manipulating its position via code.
got
Does
it.
that make sense?
So if you anchor something, you're pretty much, in a way, putting it like out of the physics system and making it act like it's just static and you can only move it if you use code. So all
Exactly.
the all
Yeah.
the free out of the box features when you anchor it no longer apply. And you have to be like really intentional with how you start messing with it after it's anchored.
Yeah, not all of them, because we'll go through some of the parts that it doesn't kind of disable.
Okay,
But
okay,
yeah,
okay.
so let's run through it and you'll see. It's always easier to learn through examples. So let's click run and we'll see what the behavior is. Okay, so this is not my computer being slow. This is just the ball is in the air. It's just statically there. And you can't really tell right now, but if we move it down a little and then run it with my character, so I still want it to be in the air just so that you can see. And then do play here so we can see how it works with my avatar. You'll see that if I run into it, it is just not moving. Like I'm trying to jump on top of it. It's still like on the ground. Does that make sense?
It,
I mean, not on the ground. It's still just stuck in the air.
yeah, that's interesting. I guess the thing that my next question would be like if we say that it's anchored, right, and it's detached from the physics system, then how does it still collide? Like so like how did you choose, if it's anchored? Okay, gravity's not going to affect it, but you can still collide with it.
Yeah, great question. And that's intentional. We did want to detach it from the physics system, but we also wanted to give you a little bit more granular control over what's on and what's off. So the granular control over collisions is actually a separate property that's called can collide.
Mhm.
So here is quiz time for you ducks. So
Okay.
let's say we turn off the ability to collide by turning off can collide,
Mhm.
and we make sure that the object is unanchored. So it's
Okay.
not
So
anchored.
it will be impacted by the physics system now.
It will be impacted by the physics system. If I run it, what do you think is going to happen?
If collision's off and it's impacted by the physics, which includes gravity, then it should just clip through the base plate. And
Isn't
it
it
clips
just
through the
super
gate.
intuitive? There we
There
go.
it
Yeah.
is.
Pretty easy to understand. See, physics isn't too scary.
Well, not
All
with
right.
you explaining it. This is great.
Let's do a second quiz. All right, let's
Okay.
move it down a little. And what if we anchor it?
Okay.
So we're going to do the opposite now. So we're going to anchor it
Okay.
and we're going to make sure that the can collision is still off. Okay,
Okay.
so anchored, can collide off.
Okay.
What do you think is going to happen when I like interact with it with my character?
So if it's anchored, so that means it'll float. And then if can collide is off, then that means you should clip through it.
There we go.
The jump in.
Easy.
Yeah. Whew. All right, two for
See,
two.
so
2 for 2.
2 for 2. Yeah, we might stop the quiz there so that you can get
Yeah, I
100%.
was gonna say don't take my average.
All right, cool. So that's two of the fun things that you can change with properties to get different behavior. The last thing I want to show you, and before I show you that, I'm going to make sure that we have it set to the default, which is can collide on
Okay.
and anchored off, is that we're going to mess around with the gravity, because as I mentioned, gravity is free here. And there's two ways of messing with gravity, of editing gravity. You can go to the workspace and there's a gravity property where you could change the value,
Mhm.
or you can go to File and then Game Settings. This one requires you to save to Roblox to be able to access them. So I won't do it for the case of this live stream, but you'll still be able to customize it, the gravity here, via the workspace. So actually what I'm going to do to show you the custom gravity is just walk around with my character and let's see what happens. So to make it simple, I'm going to round this 196 to 200.
Okay.
And then we're just going to do orders of magnitude. Or actually, let's do 100 so that it's easier to follow. So this is about half the gravity that most experiences have. So if we play here and we walk around, we jump. For those who are on Roblox a lot, you might notice that the jump is a little bit longer than normal, but okay, so this is our default, we'll call it. What do you think is going to happen when I change this gravity value to be 1/10? So I'm going to change it to 10, 1/10 of the default.
You should jump higher, or it should be like more floaty.
There we go. So this is like a really fun way of, if you want to build an experience that's more moon-like, or you can also do the opposite. So let's change this to 1,000. What do you think is going to happen if I change it to 1,000?
You can like barely jump, like not even get off the ground, just like yeah.
Exactly. Very quick. Yeah, this is also not a bug. This is just how quick you're falling to the ground. And so if you're thinking about building experiences where you just want different behavior for how gravity affects all the parts, it's super easy to customize via the workspace properties.
And you get it for free. You didn't have to like make a
for
gravity
free.
code or anything like that. It just works because you open Studio.
Exactly. Exactly.
Wow. All right, nice. So then that means then if you like drop the ball, does that mean that the ball would drop faster or slower depending on what the gravity is set at?
Yep, that's exactly what that means. And I wish there was an easy way to show it with like one ball having one gravity and another ball having a larger gravity value, but that gravity value is global.
Oh,
So,
it's global. Got it.
so it'd be kind of hard to show. I mean, we can play around with it and see if we can notice. So let's put it a little higher and let's change this workspace, this gravity to something really small. If I change it to like 5, let's see what happens if I just run this. Oh, it does work. It's pretty easy to follow.
Super slow. Oh
Okay,
yeah, and then the
so-
bounce is super slow too.
Yeah, so let's just take this, and if we move it super high, so it's gonna start falling. So let me zoom out, put it high, and then let's see if I could change the workspace value quick enough.
Hey!
500.
Oh, I saw
Okay.
it at the end.
You
That's
kinda
the end.
saw
Yeah,
it,
yeah,
yeah.
yeah, yeah.
Yeah, I mean, if we want to see it a little clearer, we saw the general speed, and we go here to workspace and change this to 500 instead. You'll see that it should fall a lot quicker. So there we go. See?
There you go. Hey, we
Super easy.
have a question in chat.
Let's hear it.
That's, can you alter the bounciness of an object? Which
Oh, wow.
I think is I think you're going to be getting to that in a little bit.
Oh, what a great question. That's a perfect segue into learning a little bit about materials. So the short answer is yes. And now let me show you how to do that. But before I show you how to do it, let me explain a little bit about materials on Roblox. So what we're going to do here is once again, create a ball. We're going to put it in the air. Remember that the default is that it's unanchored, it can collide. And then we're actually going to call this plastic ball. As you can see, I'm naming it here in the Explorer. And the reason I'm calling it plastic ball is because the default material for parts when you insert them is plastic. And then what I'm going to do is Control copy, and I actually want to put it at the same height. Oh, wait, I have my thing set to a little too granular. It's going to be hard to tell. So let's change that to 1 stud.
Oh, got it. So 1 stud at a time.
Yeah, it moves it 1 stud at a time, makes it so that it's easier to have the same height. Okay, those are the same height now. And then for this one, we're going to name that one rock ball. And we can go ahead and change the material to rock. So what you need to know about materials before we start editing their properties is that there's a set of default materials that Roblox provides, everything from asphalt to cracked lava to foil to glass, and they all have different properties. the way that you can see these properties is, so I'm going to set that to rock. If you scroll down and click custom physical properties and expand that, you'll see that all these values are different for the different materials.
Oh, interesting. So all the different materials that like lava, rock, plastic, they all have those same, what is it, 1, 2, 3, 4, 5 properties, but all of those 5 properties have different values depending on what the material is.
Exactly,
Got
exactly.
it,
So
got
if
it,
we
got it.
compare here, remember we set this one to be a rock,
Mhm.
and I'm actually going to change the color so it's a little easier to tell the difference as well. Let's change it to green. So we have a green rock and we have a gray plastic ball. So here you see that its elasticity, which is its bounciness,
Mhm.
is 0.17. And then that for the rock, so let me click for the plastic one, if we open up custom physical properties, is 0.5. So it's actually, the ball is 3 times as elastic almost as the rock ball. And so we can see how that plays out. So let's go home and remember rock has lower elasticity, has 0.17, and plastic has 0.5. So if we run it and bounce it, you saw a little bit that the ball bounced more, the plastic one bounced more. We can actually
Got it. So the
see it a
bounciness
little
is
bit better.
elasticity?
Yeah, kind of. Yeah, that's a simple way of thinking about it. So let's change this gravity a little lower so we can see a little bit more of it.
Oh, there
Yeah,
it
as
is.
you can see, the rock actually like bounced a lot less. And even though it's the exact same size, exact same height, and exact same gravity.
Interesting. So,
And this can enable some funky behavior if you want. Like traditionally, you'd think that a rock is less bouncy than a plastic ball, but thanks to custom physical properties, you can mess around with that. So for rock, we can change that elasticity to be 1 and change the plastic one to be 0.1. And now you'll have a rock ball that is a lot bouncier than a plastic ball, which once again, now this isn't intuitive because it's not the default custom materials or default material properties, but it is customizable, which creates for really fun gameplay.
interesting. That's really cool. That's a lot of freedom.
Yeah, it's really easy to use and really intuitive with the different properties that we have. And I'd love to show you some of the other ones if you're interested.
Oh, of course. That's why we're here. We've got another
Perfect.
question in chat for you. This is
Okay.
circling back to gravity. So the
Okay.
section before, we're on material properties now, gravity inclusion before. Gravity, if you change the global gravity property value, how does that impact water? The question is, does water count? But how does that, is there any unique interactions with gravity and water? Like if you're moving, like if you're swimming, will that be different? Or what would that
Oh,
relationship look like?
that is a great question. And I don't want to give you the wrong answer. I'll give you a little teaser as we are always working to improve all our systems, including our hydrodynamic system.
Hmm,
And so I'm just not sure what the latest force model is right now for hydrodynamics. So
got
I'm
it.
not sure how gravity affects it, but I can get back to you and we can reach out to that user. But that's a fantastic
Got
question.
it. So the short answer is yes, it does impact it, but because Roblox is a physics simulation first engine, that means it's going to be extremely scientifically accurate, such that you use the word hydrodynamics. So so that just means that yes, gravity does impact the hydrodynamic system, but that's currently out of scope for the contents of Physics 101.
100% out of scope for Physics 101. That is right.
Okay, but there is some relationship there, but the specifics we'll have to circle back on.
Exactly.
Amazing. Okay, cool.
All right,
So
awesome. So
far,
next up
yeah.
is
What's
the
next?
next material property, if you're okay with that,
Oh, of
which
course, yeah.
we're gonna do friction, if
Okay.
that's cool with you.
Yeah.
All right, so the first thing we're gonna do here is create a ramp. And the way to create a ramp is use a wedge. Whoa, that put it really far away. And then let's make sure that it's on the ground there and let's scale it up so that it's really easy to see. So we'll make it big like that, and like that. We're actually gonna make it a little lower. Okay, perfect. And now we're gonna put 2 spheres on it. Actually, before I do that, given that the ramp is big and I'm planning on putting some smaller balls on it, it shouldn't be too important, but I actually don't want the ramp to move at all because I want to just show how the friction, ooh, that's not what I want. Let me delete that and insert a new one. I want it to be standard size. Perfect. Okay. Given that I only want to show you how the different friction values on these 2 spheres change its behavior. I don't want the ramp to move much. So do you have any suggestion on how to make the ramp not move at all?
Anchor it.
There we go. Easy. 3 for 3
Easy.
on the
Woo,
quiz.
still at 100%.
Still at 100%. Exactly. Okay, so we're going to anchor the ramp, but not the spheres. And we're going to make sure that we have another one here. And we're going to move that one directly to the side and then down. Okay, so let me make sure. I'm actually not positive that these are in the same place. So let me make sure that these are. Let's
Exactly
create
the same.
one.
Because, I mean, again, because Roblox takes its physics very seriously, if they're not exactly on the same, level, then the one that's higher would have a different acceleration and different stats because of, where it is on the
Exactly.
slant.
Exactly. So that's exactly what I'm doing here with just making sure that we have it in the exact same place. Okay, so that went under it. We want it right above. Okay, perfect. So we have these two balls here, and what we're going to do is color them and change their friction values.
Okay.
So for the one with lighter friction, we're going to make that, let's do light blue. And then the one with greater friction, we're going to make purple. Hopefully that's a little intuitive. A darker color for more friction.
Perfect.
And then we just need to click on each one. Make sure that, oh, I need to click OK here. Make sure we have custom physical properties on, and then just change the values significantly. So for friction, let's go to 1. And for the lighter one, let's change that to friction of 0.1. Okay, so let's double check that we have that set up properly. The lighter colored one has friction of 0.1. The darker colored one has a friction of 1. So 10x difference in friction. What do you think is going to happen here when I run this?
Well, in theory, shouldn't the one with more friction, slow down faster because it's, that stat is higher when it's interacting with the ground?
You'd think that, and that's my guess too, but let's see. All right, let's see. Oh, it looks like they're side by side. And you know what? Now that I think back to my physics class, I think I remember what's going on here. So funny enough, friction is really only pertinent when like the faces are sliding against each other.
Interesting.
So for example, if I slide this base plate against the ground like that, that's when friction comes around.
Mm-hmm.
But because the spheres always have one point touching the ground and they're constantly rolling rather than sliding, that's why friction here didn't make a difference. I'm pretty sure that changing this to blocks will. So let's try that out.
So just to make sure that I'm understanding what you're saying, the reason that the friction didn't work is that friction works when you're sliding something, meaning like the base plate, like a piece of paper, all the way flat across the ground. And you're getting friction like when you rub your socks over the carpet. It's that same flat thing. But when a ball is rolling, you have one point of contact between the ball and the floor. And that one point of contact is always changing because the ball is always rolling.
Exactly. And fun fact, if there was no air resistance in real life and like we didn't lose energy due to like sound or anything like that, this ball would continue to roll forever, just the way that you saw it right now on Roblox. So though it looks funky, this is actually pretty accurate considering that as it stands right now, we don't have aerodynamics on. So later in this live stream, I'd love to show you how that behaves differently with aero, if you'll let me.
Yeah, of course. So it sounds like then so basically you just kind of hinted at the fact that if you want a sphere to slow down, like, Indiana Jones style, like you want to have something chase you, you want something, you want a ball and chain to, move around, and you want to slow it down, you can't use friction on a spherical object because that won't work with the rotating single point of contact with the ground. You would have to instead, it sounds like you said aerodynamics?
Yeah, aerodynamics would provide the air resistance that we see in real life. Yep.
That would get us farther than the friction would.
Exactly. I'll show you that. But the friction will cause behavior difference in blocks where you actually have the faces.
Okay, got it. Slide. So now if we use it, so if we do like a cube or something.
Yeah, exactly. Let's do a cube.
Perfect.
All right, let's make it a little steeper here. And if we go ahead and add a block, I need to stop leaving it in scale mode. It always screws me up a little. All right, cool. So we have that one there, and we're gonna make a copy and then just make sure we move it and keep it at the same level. All right, same thing as the spheres. Okay, we have these two. We're gonna put them over on the ramp here. And then, all right, this should be good. They're gonna fall and then slide. And we're gonna do the same thing as last time. So we're gonna click on the first one and we're gonna color it a lighter color for lower friction, light blue. Go to custom physical properties and set that friction to 0.1. So this will be our low friction block. And then for this second one, we'll color that a darker purple. Put OK. Go to custom physical properties and then set that friction value to be 1.
So the same thing. Darker color means more friction.
Yep, exactly. And so what do you think is going to happen here? Let's go for round 2.
Okay, what am I at? 3 for 3? All right. So if the darker one has more friction, then more friction should mean slow faster. So the purple cube should slow faster than the teal one.
That's what I'm thinking. So hopefully we're both right. Let's just make sure this ramp is anchored. All right, we're good. All right, so if we run this,
it doesn't even move.
God.
Love it.
It had so much friction that it doesn't even move. Let's actually see if we can make it move by slowly decreasing it. Yeah, but we already saw there that the exact same blocks, exact same height, exact same setup.
Yeah.
It won't move, but the friction is just too high. So maybe 0.6. There we go. There we see
now
some
it's
sliding.
Slowly sliding. And it's just, I'm sorry, like it boggles my mind that this is like, you can make like really cool interactive experiences. You don't have to, none of this is involved a lick of code at all.
Isn't that so cool?
Like you could make a whole experience just with physics. Like
I know, right? I think it's the most fun way of building on Roblox.
It's pretty slick, and it just makes sense because you real life uses physics, like in the same way with ball bouncing and slowing down. Like, man.
Yeah, very intuitive stuff. You're kind of just like, hey, this works in the real world. Let me try it in Roblox, and most of the time it does.
Perfect. Sweet, man.
Yeah. Cool. So we have one last property that I'd love to show off for Physics 101.
Okay.
There are 3 more. So if we look here, while I have this pulled up, we have a total of 5.
Okay.
We already talked about elasticity.
That's the bounciness.
We talked about that's the bounciness.
Yeah.
We talked about the friction. That's kind of like
I just did.
We're gonna talk about density.
Okay.
But I'm gonna leave elasticity weight and friction weight for a future Physics 102 or 103 stream, and also for our users to go read up on themselves on the technical docs, just because it's a little more complicated and just isn't worth it right now for 101. So let's talk through density, okay?
Okay, perfect. There's a great question in chat after you do your density bit.
Okay, yeah, the density will be super quick, so
perfect.
we'll get right to it.
Awesome.
All right, so I don't want to cheat anything, so let's just delete everything and start from scratch. And let's start again with a sphere. So we have one here. It's just against the ground there, and we're going to copy and paste it. Okay, cool. And we're going to color these. So this one on the right side is going to be red, and that will be higher density. And then this one on the left side will be, let's go light blue. I was going to go pink, but maybe that'll be too hard to differentiate. So light blue, we're going to do less density, and red, we're going to do more density. And what I need you to focus on here to understand this or see the effect is actually just this mass that's grayed out. Do you see it? Do you see the 23.457?
Let me zoom in a bit. Yeah, this is going to be scuffed, all right? We're going to have to zoom in a little bit. I just want to make sure we can read this. All right, barely. All right, go. So the density, it's grayed out. It's like 23.457.
Yeah, so the mass is grayed out. The density is not grayed out.
0.7.
Yep. So we're going to turn on custom physical properties for both. As you can tell, the mass value is 23.457 for both of them.
Okay.
And what density is, you can look this up in case you ever forget. Density is mass divided by volume. And the way to think about it intuitively, please don't quote me in a physics classroom, is that density is kind of like the thickness per se. It's like given the same volume of an object, so the same size sphere,
Mhm.
if one is thicker, you'd expect it to be like heavier, right?
Oh,
So
interesting. Yeah,
higher
yeah, yeah.
density, usually higher density for the same volume means higher mass, and we
Uh-huh.
can see that. So for the red one that's supposed to have higher density, we're just going to double the density here.
Okay.
So from
From
0.7
0.7
to
to
1.44.
okay.
And let's look at what happens to the mass as soon as I press enter. So it
Oh, I
goes from
just zoomed back out.
23.
All right, I'm gonna have to zoom back in. So you're doubling
Okay,
it, right?
I'm doubling it. I haven't pressed enter yet. You let me know when you're ready.
Okay, let me zoom back in with this really scuffed zoom. Here we go. Here we go. Here we go. All right, 1.4K, ready, go.
All right, ready?
Yeah, yeah, yeah.
And we see that the mass exactly
It
doubles.
doubles it, like exactly.
Mhm.
Wow,
Exactly
just like
doubles it.
that, just mathematically simple as that.
Easy, easy peasy. Same size ball. One just is a lot heavier because it's a lot denser. Or by a lot, I mean double.
Literally double. I mean, that's a lot. I'd say that's a lot.
Yeah.
All right, so this actually is a really great segue to the question that was asked after I finished zooming this out again. Okay, so the question that was asked is related to density and then how, like, basically why that stat matters. It's if you were to increase the density of an object, given that volume remains constant, would the friction increase leading to a lower velocity? Or is the velocity purely dictated by the friction?
Oh, okay. You're gonna have to slow it down for me. Could you repeat that a little
Yeah, yeah, yeah,
slower?
yeah, yeah,
Okay.
yeah. I could also copy and paste it for you.
Sure. You're gonna message it to me.
Yeah, let me just ping you here
Okay.
so that you can also read it. So I'll read it
Alright,
again. It's if you were to increase the density of an object, given that volume remains constant, would the friction increase leading to a lower velocity, or is the velocity purely dictated by the friction?
Oh man, I mean, this is a great question because I love that you're already you're already combining all these properties and trying to see how you can get some cool behavior. It really depends case by case. So for a ball, we already said that because it's rolling, the friction doesn't affect it. So here, um, these should, and let's just test it. I mean, these should roll the same speed. So if we do that and scale it up, go like that, and then rotate it 90 degrees. Oh, oops. All right, rotate this 90 degrees, scale it to the side. And then we take these two that have this different density, right? So
yeah,
here
because the
we
red
have,
one's
if we
heavier,
were,
right? The red one was double.
Yeah.
Okay.
yeah, I'm gonna double check that because I don't want to screw up the question. But if we put these both here, okay, so these are in the exact same spot, and then red has 1.4 as density, and blue has 0.7 as density, and we just run it. I'm pretty sure they just run at the same time. Yep, there we go. So I could show you the proof where the mass basically cancels out of the equation for the speed of the ball. But honestly, I think the most fun way of exploring these questions are just to build it out yourself. I mean, that's the beauty of Roblox. It's like, hey, I have this question as to whether or not density affects the ultimate velocity. No need to go do the math. Just build it out
Just tinker
and
around with
test it. Yeah, exactly. But yeah, to answer this question, if you were to increase the density of an object, the velocity in this case stays the same because friction isn't affected. All you see here is that it's the gravity's acting on it, and gravity will act on both objects the same.
Got it. Because it's a global setting.
Yeah, exactly.
Got it. Okay, sweet. Nice, so that's density. Literally just double the mass stat.
That's right. Easy peasy. I think we have aerodynamics next. Is that correct?
Yeah, that's right.
All right.
Which is actually great because you suggested that, or you hinted at, that aerodynamics would be more efficient at slowing down, the spheres rolling down the hill instead of the friction for the cubes.
Yeah, that's right. Let's do that example. I think that'll be really fun to do. So, okay, so the first thing that you need to do if you want to mess around with aerodynamics is it's currently a studio beta feature. So you're going to have to go here to File and then Beta Features, and then turn on aerodynamics. And then you can click Save. And you actually don't need to restart it right away. It should just automatically work. All All right, so we have aerodynamics enabled there. And the last thing you need to do here is go to your workspace and change the fluid forces from default to experimental. So now we have air in the general world, and that means that we'll have air resistance. So let's build out that exact example that we had before. So we're going to make a ramp here. I really should just have a ramp on deck. I keep building
You
up
keep remaking the same ramp.
I keep remaking them, but it's actually pretty fun to use these like tools. So no regrets.
Again, because it's intuitive.
Yeah, it's just pretty fun. All right, so we're gonna move this down. And then let me just rotate it so I don't have to move my camera. So we're gonna rotate this 90, and then let's just, all right. That looks pretty good. I don't see why not. Maybe a little lower. Okay. And once again, we're going to anchor it. We don't want it to move. We just want to see the different behaviors of the balls. So once again, let's create 2 balls here. Let's move it here. Ooh, let's not make that mistake again. We're going to move it there. Copy paste it so that it's side by side. And then move them onto the ramp. Okay. Okay, are these completely against ramp there? Yep. All right, perfect. So the way that we're going to showcase how air resistance and aerodynamics actually affects these balls that are going to roll off the ramp is by having one of them affected by aero and the other one not. So how about we do no is red.
Can I pick the colors this time? You pick the colors every time.
Yeah, why don't you pick the colors? What do you want no to be?
I want no to be green.
Okay.
And I want yes to be red.
Like oh, let's confuse everybody. No, I'm just kidding. We'll follow it. And I'm actually going to name them to make sure that we're good.
Just to be clear.
Red is yes, arrow. Can I put an exclamation point in here? I've never tried. Yay, yes, arrow.
Nice, nice.
And then green is going to be no arrow. And let's see if I can put a sad face. Oh, perfect.
Hey,
I like it.
Okay.
All right. And so what we need to do to make this no arrow and yes arrow, because the names aren't enough, are turn on and off this enable fluid forces behavior. So for no arrow, we want it disabled, right? We don't want aerodynamics. And for yes arrow, we do want aerodynamics.
Okay.
So let's talk through what we should expect.
Sorry.
Yeah.
I'm a little confused. So you're saying aerodynamics, and I'm tracking. Aero means air. We're talking wind resistance, the one point of friction on the ball. Like that's all tracking. But then as soon as you enable the beta feature for aerodynamics, you said that it's called fluid dynamics. Like, why is it fluid? I thought we were like, it's like air stuff, you know?
That's a great question. And I kind of alluded a little bit to it earlier. So fluids are both liquids and gases.
Oh man, here we go.
So we started with aerodynamics, which means, how do the forces from wind and air resistance affect objects? But eventually we want to incorporate that with all liquids as well. So you can imagine building a sailboat that is completely accurate from the perspective of how does the water affect its behavior? How does gravity affect its behavior? How do collisions affect its behavior? And how does the wind force it to move in a certain direction with a sail or whatnot? Does that make sense?
Yeah. So that this is circling back to that gravity water question.
Exactly. So that enable fluid forces right now is talking about the aerodynamic forces. But in the future, you can envision that it'll be air and water, or better way to put it is gases and liquids, because air is just one type of gas. Like we could change the density and mimic some other gas.
Got it. So you're just future-proofing the naming conventions on a technicality.
Trying our best to future-proof it so that we avoid confusion as much as possible. I mean,
that's great. Yeah, imagine using aerodynamics for years, and all of a sudden they change the name.
Yep, exactly.
Okay, that makes sense. All right, okay.
Cool.
All right, I'm tracking.
So awesome. So let's walk through this again. We have a ramp. It's anchored because we don't want it to move. It's a little bit sloped so that it should be providing some sort of like force for the balls to roll down. We have a green ball that does not have aero enable, and we have a red ball that does have aero enabled. And so we've already talked about air resistance a little bit. If we if we know that the red ball will experience air resistance,
Mhm.
what do you think will be the difference in behavior when I run this between the green and the red ball?
The red should slow down because that's like the primary thing that would be slowing it down in this example.
I'd hope so, right? Let's
Yeah.
see if it works. So
I mean,
let's
if
run it.
friction didn't slow it down, then like balls are just broken and unstoppable.
Exactly. And so it might be a little long to notice it, but
Oh, yeah, no, there it is for sure.
it's definitely taking a lead. And the easiest way to show it is if we give it 30 seconds, it will roll off here. But another way that we can show it is actually changing the global wind. So which way is X, Y, Z right now? Let me stop this and rerun that. So I'm actually going to turn on global wind in the positive X direction, because if you can
Okay.
see my cube here, that means it should make the ball that is affected by air roll backwards towards the ramp. So let's go ahead and run that. We'll let that run slowly in the background there. And then in workspace, we can go and change the global wind. So right now it's set to 0, 0, 0, which means there is air resistance, but there's no wind. And if we turn this to, let's say, 20, so 20 in the positive X direction, as I mentioned, it should start going back towards the ramp. Let's see. It does look like green is
it's slowing
taking more
down.
of a lead. What if I turn this to like 200? Will it just like go super
Just
fast?
rocket it. Oh, yeah, there it goes.
Oh, there it goes. And maybe we changed the Z value to make it go up or down. So 100. Oh, and it started veering off down.
There it
Oh no, we're
goes.
gonna lose it. The green one's still going unaffected.
Unaffected because by air resistance. But the
I
red
think
one just zoomed off.
the red one just zoomed off. We have green here that's just still rolling, minding its own business.
And green can just go forever because it doesn't have the friction to slow it down, and it doesn't have the air
Exactly.
resistance to slow it down. So there's kind of nothing stopping it at that point.
Not unless it collides with something,
Unless it
which is
collides with
also
something.
free physics. Yep, that's right.
So, okay, this might sound silly, but so when you enabled the aerodynamics, right, just to have it exist and toggled it on, before you did the really dramatically obvious global wind, right, where it moved backwards in the opposite direction, you like made a little like you could do like hurricane winds, right? Like, what's the point of just enabling latent normal wind resistance? You know, like the global wind setting makes sense. Like, oh, I want like a big gust of wind. Like, oh, I want a tornado. I want a hurricane. I want like crazy wind. But like, what's the point of just toggling it on? Is it just to do global wind, or like, does it have value in and of itself?
Yeah, that's a great question. I mean, it's really just what we started this whole stream with. It's mimicking the real world. Like most developers or most users here would expect that a ball would eventually stop rolling. And as you can see, that is the case for the red ball that has arrow enabled, and it's not the case for the other one. And so you just get more realistic behavior, more intuitive behavior by turning it on. You can always use it for gameplay specific stuff, as you mentioned, with like applying some sort of wind. But also what this does is it enables stuff like if you have an airplane, for example. I wish I had an example. That would have been really cool to bring into this live stream. But if you have an airplane that's just like going fast enough and tilting its wings up, if there's no aerodynamics, that thing is not going up. I mean, there's no force to push the wings up. But with aerodynamics enabled, even if it has no global wind, you can start flying it the way that it happens in real life.
Interesting. So in the same way, like if you jump out of that airplane with the parachute, like you have gravity, sure, then that exists free out of the box. But if you keep gravity so you fall at all, but then you have aerodynamics enabled, the parachute would actually impact the rate at which you fall.
You're picking up on this really quick. Yep, that's a great example. I mean, with aerodynamics enabled, you'll get a realistic parachute behavior where you actually kind of glide down and slow down. But without aero enabled, without any air in this experience, like that parachute's just gonna fall down
at the same rate
speed
as you with the gravity.
Exactly, 100%. Let me show you another fun thing with aerodynamics here that you can see some more custom character behavior. So all we're gonna do here is, as you remember, aerodynamics is enabled and we have global wind set to 0, 0, 0.
Okay, so no crazy winds, but aerodynamic does exist.
Exactly, air exists, and we do play here. We just have our character walking around. Okay. Yeah. So if we were just walking around here, cool, right? Remember the jump is kind of affected by the gravity, but you could also have it affected by wind. And the way to think about it is that wind is just applying a force in a certain direction. So we can apply it in the x direction, which if we remember is to the right. Let
Mhm.
me double check that. So positive x is to the right, positive z is towards me. So if we play here and we go and turn those values up, we'll see what happens. So for global wind, let's put an x value of like 600. Or yeah, 600 should be good. Oh, he's already
Oh,
starting.
shoot.
I am not touching the keyboard.
He's just slowly starting to be blown away by the global wind.
He's slowly moonwalking. No, I'm just kidding. It does look like he's moonwalking, but you can see this behavior a little bit more where I try to run left and then slow down, and especially when I jump. See,
Oh,
I'm
shoot.
jumping left
Yeah.
and I'm getting blown back right. But if I run right and jump, I like,
Oh, look at that.
and that's all from this global wind. And let's see, if I turn this to 0, you'll see that that's not the case. I can just walk left, walk right, jump right, all normal.
Yeah.
But I can also turn up the Y value here. So this is literally pointing up into the sky. And if I give it a value of like, let's also try 600, because why not? I'm still on the ground because it's not enough force to get me to fly. But now when I jump, like there is a lot of force keeping me up in the air because of the arrow. And so I'm just kind of floating there. Whereas if I turn this to 0, like I should just fall.
Got it. There was a question earlier if you could invert gravity, or, so you can make the gravity go up. And it sounds like that you can't. So gravity's always down, but you can kind of have a similar effect by doing arrow in the Y direction. Is that accurate?
That's one way of viewing it. Yeah, I mean, gravity, let me double check to make sure that I'm not lying. Yeah, gravity can never be negative.
Okay,
so it's always going to point down. You can have it set to 0, but that just means there's no gravity. And the way to think about it is gravity is a force pointing down, and you're giving a magnitude here of like how much. And global wind can be a force going up. So if I put this to 1,000, for example, that's actually going to be so much that my character just starts flying. So you can never change gravity so that your character starts flying, because we don't currently let you change the direction of gravity.
Yeah, because we're trying to be realistic. It's like a realistic
exactly.
physics engine.
Exactly. But with wind, you can set a value high enough that you start changing the behavior by either jumping higher or just flying the way you saw me there, or combining these crazy values of like, imagine both X and Z are affected. So we'll do double the value in X as Z, but still a lot. And then I start getting pulled in, like diagonally back to the right. Like all this is possible through aerodynamics. And it just happens to be that if you set it in the Y value, it's counteracting that of gravity.
Makes sense. Sick.
Following so far, any other questions that we should take care of?
This might be out of scope, but there was a question of somebody was wondering if they wanted to make a tree not be impacted from global wind. Would you just anchor the tree? So the question is, if you wanted to apply aerodynamics, to example a tree, would anchoring the tree model cease the aerodynamics?
Yes, in that the force would not affect the tree, but also, if you remember, we already did this with the 2 parts, and all you need to do is turn off the enable fluid forces. So if you want the tree to be subject to other forces, let's say the tree is a heavy tree, but if you run into it with a car, you want the tree to move, but you don't want it to be affected by wind, all you need to do is click on the tree and turn off enable fluid forces.
You don't even have to anchor it. You can just turn off.
You don't even have to anchor it. Yeah, exactly. But if you just don't want the tree to be touched at all by any forces and you just want collisions, then you can anchor it. And if you don't want collisions, then just go turn off can collide. Easy peasy.
That's actually insane that you have like 3 different tools, like levers you can pull. You can anchor it, you can turn off fluid forces, you can turn off can collide, all on the individual part level. None of those are global settings.
Yeah,
on that individual tree, you can customize it.
And this is just Physics 101. We got a lot more stuff, a lot more cool stuff that you can do with this really cool physics engine.
Bananas. All right, hey, so at 3:55, we got around 30 minutes left. 15 of those are Q&A, which means we got about 15-ish to talk about constraints.
All right, let's do it.
So quick context for constraints, though. Or I guess to recap. So we just covered a bunch of things that came for free. that you might not realize come for free. So gravity and collisions, material properties, and aerodynamics. And we did a bunch of examples showing all of that. But now for the second part, you mentioned there's two parts. That was the first part. This part is now getting a glimpse, like a beginning peek behind the curtain of tooling of how you can like customize the free stuff that we get further, or like examples of how that could be used more advanced. Is that correct?
That's correct. And
Okay.
I'll add a little caveat that we already showed a little bit about the customizing that free behavior through properties,
Mhm.
which were like, is this part anchored? Is this part set to can't collide? Does this part have fluid forces enabled, etc.? So this is already customization of the free physics, but right now the constraint side of stuff is specific tooling that is really, really powerful, really cool stuff that I'd love to show off a
Got
little
it.
bit.
Yeah, let's do it.
All right, awesome. So the first thing I'm gonna do here is turn off Aero because I don't want that to be changing anything. So let's make sure that I have it off. Go to beta features, turn off Aerodynamics, save. Don't need to restart that. All right. Cool. So at a very high level, what constraints are they are tools that are meant to constrain the motion of specific objects in your experience. And I know that sounds silly to use a root word in the definition, but let's talk through it in terms of the two categories of constraints. So can you see my technical docs
I can.
website here?
Can
Okay,
you
awesome.
control plus? Can you zoom in just a bit?
Yeah, absolutely. All right.
Perfect. And then Mod,
Perfect.
could you share the link to this too, people? If chat, if you guys want to bookmark this, if you want to look at it later, this is really really handy.
Awesome. Yeah, so we have two classes of constraints. We have the mechanical constraints, which constrain how objects move with respect to each other. And so the easiest way to understand this is by looking at some of these wonderful videos that our teams have put together. So we have a hinge where something can rotate about another object, as you can see here. Are you able to see that,
Yep,
Dux?
perfect. It's
Awesome.
playing.
Yeah, we have stuff like a spring. This one's really fun to mess around with. As a little teaser, you do have tons of properties here so that you can change how stiff it is, how much it dampens, etc. We also have a rope, which is always useful, and it behaves exactly as you'd expect in real life, where you can set the length of the rope, and then it actually does have a mode where it can become a winch, and it like kind of like pulls it in, kind of like a tow truck type of
Interesting.
deal. But that's not for Physics 101. We'll get that there eventually. So that's mechanical constraints. Honestly, my suggestion is for anybody who's curious, just go to this doc and just look at the videos and read through these short descriptions, and I'm sure you'll be motivated to try something out here because they're so cool. And then the second half of it is mover constraints, and this one is something that we'll go over in future sessions because today I really only want to go through the hinge constraint. But the way to think about mover constraints is that they make objects move either linearly or rotationally by controlling their position, their velocity, or their acceleration.
Okay, that's
And
a
so,
lot of words. Can we watch a video really quick to see what that looks
yeah,
like?
yeah, exactly. So here you'll be able to make this object move linearly by controlling its velocity on like how fast it's moving in a certain axis, but indicated by that blue arrow.
Interesting.
The analogous version for rotational is just rotating at a certain speed. But you can also you can also control its acceleration, which is done through force. So it might be a little hard to note here, but if you are applying a constant force to an object, it's actually going to accelerate. So here its velocity is getting quicker. It's getting higher as time goes by. And similarly for its angular counterpart. So you're applying some torque to it, and it starts at 0 and then slowly starts speeding up. Exactly.
Wow.
So this is probably going to be a Physics 102 topic, but I did want to highlight this just so that once again, those who are curious can go read our docs and look at these videos and try them out in studio. Honestly, the best way to learn is always to just tinker around with them.
Got it. So mechanical constraints is what we're covering now, and then mover constraints are kind of a teaser, forward-looking, that are a little more advanced.
Exactly. And we're only going to cover one of the mechanical constraints because it'll give an intro into how our constraint system works.
Got it.
And so what I propose we do is we build a basic hinged door,
Sweet.
something that most users probably see every day and can kind of intuitively think about when they're building. How does that
Perfect.
sound?
Let's do it.
All right, cool. So there's going to be two parts to this door. We're going to have a frame. So let's make this a block and pretty tall. So we're going to have a frame like that. And then we're going to have a door. So I'm going to move this over to the right, put it down to the ground, and then just make it wider so that it's easy to tell that this is the door part. I know this looks like a funky door, but let's make it look a little more realistic very easily. So for the frame, I'm actually going to change that to, how about you choose the material? What do you think for the frame?
Let's do like something metal.
Something metal. How about metal?
How about metal? Perfect. Great.
How about metal?
Metal
And
seems pretty metal.
what color metal?
Let's do red metal.
Ooh, I like it. All right, red metallic frame. And then for the door, I'll choose wood, but I'll
Okay.
let you choose the color.
All right.
What color wood?
Let's do blue.
Blue wood. I love the creativity. Let's do this blue.
Oh my gosh, it's so blue.
Maybe a little lighter blue,
Yeah, sure. Why not?
a little less
So
jarring.
we can see what are
Yeah,
what are
let's
that
do
called
this.
in their seams? What are those called?
Are they striations?
Striations?
Is that the right word? I'm not
Fibers?
sure.
This is physics. All right. Anyway, making
It's
it
just
dark.
materials. Yeah, exactly. Cool. So we have our frame and we have our door, and now we just need to constrain it with a hinge. And so there's two ways of going about this. You can either use our constraint tool here that's under the model tab.
Mhm.
Right here under create, you can pick which one you want to use. Or the other way of doing this is, and also what I'm going to do here is change the name here so it's a little easier to reference. We're going to put that as frame, and then this one should be door.
Oh, it's wood grain.
Wood grain. Thank you.
See,
I'm assuming that's a audience member, right?
yeah, that was a mod.
Shout out to the audience. We appreciate y'all. Cool. So we have a frame and we have a door. And the second way of doing it, if you don't want to use this constraint tool in the ribbon, is to go ahead and, for example, add a hinge constraint instance. So you can add a hinge constraint, and hinge constraints operate using attachments, which we'll get into. But if you do it this way through the Explorer, you'll have to manually parent the attachments. I'll get into it. My preference is always to use the constraint tool because it's a little bit easier.
Okay.
So
Could you show us from the beginning? So if we have the two parts here, and there's this confusing word constraint that isn't really clear what it is, the first step would be to go up to that tab under what are we in model?
Yeah, so we'll go from home to model.
Model.
And then under the constraint section, we're going to go to create and select hinge.
Got it.
Okay, so you get this funky yellow arrow, which I'll talk through. These are the attachments that I'm talking about. And the way to think about attachments is that these are the positions of each object that you're constraining that you want to be, for the most part, together. So think of them as magnets in the same place. I'd say for the most part, because in certain cases, like a spring or a rope, they're actually meant to be distanced. So you can imagine like the ends of the springs are the attachments or the ends of the ropes are the attachments.
Oh, sure. Okay, that seems to make enough sense.
But for the hinge constraint and for most other constraints, they're actually just kind of magnetized. And so I clicked the first one, right? I want to.
So the first air quote magnet, the first attachment.
And if you see here in the Explorer, I actually got parented to the frame, which is exactly what I want.
Okay.
And then I'm going to pick the point closest to it right here on the door.
Okay.
But I'm actually going to make sure that this is 0.5 so I can get a little bit more. I want it to be right on the edge like that. Okay, so we constrained it. Now let me talk through some of the confusing parts because I know this is a little confusing. As I mentioned, if you were to do this via the Explorer, you would have to create a hinge constraint, as you can see here, and two attachments. And what this tool up here did is it automatically parents these two attachments that used to be empty.
Yes.
So if I go here, right click and go to reference object, you see that this is the attachment.
Sure.
Yeah. And similarly, attachment 1 is the second one. So if I were to change the name here and do frame attachment, and maybe I can do this quicker. Door attachment. Take off that one because it looks a little funky.
So now we have frame attachment and door attachment.
As you can see, they were automatically parented here under hinge constraint.
Okay.
Are you
So
following so far?
would it be accurate to say that a constraint in like a metaphorical high level way, if the attachments are like magnets, the constraint is like the system that holds the magnets? I know there's exceptions because of course some attachments are like at the end, like a rope or a spring. But
Yeah.
if you say like, oh, I'm going to use this constraint, mentally you can almost view it like, okay, I'm going to use this system that's going to involve 2 points called attachments that will kind of sort of work like magnets most of the time.
Exactly. And the system is what dictates how these 2 parts can behave with each other. So
Got it.
if you think about a hinge on a door, all it's really saying is like, how can this door rotate around the frame? And so a lot of this, as I mentioned, is easier to understand if you just tinker with it. So we set up the hinge constraint.
Yep.
Let's just do play here and see what happens. Okay, the first thing we learn is that I created a huge door. So
Hey.
let's see what happens here. And I push it. Oh, weird. It completely
It just
fell
falls
over.
over.
Yeah, I think this is time for another quiz question. What did I do
Anchor
wrong?
the red part.
That's right, exactly. All we want is for the door to move. And so what I'm actually going to do is make this a little bit smaller. So let's scale this down. Cool. We'll scale it to 8. And that's right. We don't want the frame to move, right?
Only the door.
We only want the door to move. And so what happens if we play here? Okay, so first thing to note, actually, because I think it's really important to walk through this slowly, we're just going to run it. We're going to see what happens as soon as I press run.
Okay, not play, just run.
Just run.
Physics.
Just the physics.
It snaps together.
Yep. And if we take a look, that is because, as you mentioned with these attachments, they're kind of like magnets. So there's the attachment from the frame, and here's the attachment from the door. I promise you I'm selecting 2 separate things.
Oh, but they're like right on top of each other.
Exactly.
So is that, could you show again if you just hit play so we can see it snap back in?
So if we just press run here, it just snaps there because that's where the attachments are told to go.
Perfect. Oh yeah, I said play, I meant run. You got that. Thanks.
Yep, exactly.
So then you mentioned that you changed your stud distance specifically so you could put the attachment at the end of the door to get them lined up precisely. Why does that matter? Even you clicked on them and it's like, oh, I'm clicking different ones, but they're right on top of each other. Why do the attachments or the air quote magnets have to be like right on top of each other, and like the arrows and like what are those?
Yeah, that's a great question. So the reason that they need to be right on top of each other is because if we don't, so let's just see what happens if we move them. The way that our system is set up, so let's just put it right in the middle. We moved it over 4. We can remember that for next time.
Okay.
If we don't and we run, our system is set up so that 2 objects that are constrained together with this hinge constraint, they can't collide with each other because if you remember, let me undo that and run through. So right now we have the attachments in the right place and we run it. If we take this object and move it, which should move with the hinge constraint, so you can see that it's like rotating about. But if we zoom in, you see this clipping?
Yeah.
This is intentional. It's so that, this door is meant to rotate about this frame. We don't want to make it extra complex for you and make it so that you have to think about every single corner. What most developers usually care about is, does this door rotate about this frame? And if so, where's the axis of rotation? And so what I'm getting at with that is if I have the attachment somewhere in the middle, it's going to give really funky behavior.
Oh, got it. So since there's no collision, basically the magnets will overlap on top of each other. Like you can't stop their power. So
the magnets will be magnets. Exactly.
The magnets will come together. So you have to place them such that it doesn't bork your scene.
Exactly. And so that's why you want them to be right where you would expect them to be in real life. So you would want to attach the edge of the door with the edge of the frame. And that way, when you run it, you get this kind of intuitive behavior.
Perfect.
So let's do this now with our character to see what happens. So let's go ahead and play. We made the door a little smaller so it's more realistic. And then we walk through it and we see that you can literally see where the object is rotating about. And so we can turn on this, this hinge constraint. And you can see here that this little orange symbol here is actually where the door is rotating about. So if I run into it, it's just
Oh, that's a good angle.
rotating
That's a
right
good
there.
angle. Yeah, yeah.
Yeah.
So
You see
like
that?
that orange like little circle around it.
Mm-hmm.
So
That's the rotation axis.
so if you want to know where it's going to rotate, know that it's whatever the attachments are on, it's going to rotate around the circumference of that orange circle. So it's going to
Yep.
follow the outline of the circle. So since that is horizontal, the door is going to be doing the swinging motion that we're seeing here.
Yeah. And so the important thing to know here is that this orange circle is dictated by the primary axis, which is the yellow axis, the yellow arrow.
Got it.
And we'll get to the importance of the secondary one.
Mhm.
But the thing to know here is that each constraint uses the primary and secondary axis in their own way. With respect to the hinge, it tells us how is this object allowed to rotate. And so if it's allowed to rotate about this yellow axis, that's why both of these are set to yellow.
Got it.
Pointing up, that's where it rotates. I have another quiz question for you.
Yes.
So you noticed that when I push this door, it eventually slows down. Why do you think that is?
Oh man. Oh well, there's enough surface area on the bottom of the door that it's probably friction because aero is off, right? Fluid dynamics are off. So the only reason why I would stop is friction, right? Friction, final answer.
Exactly. And you're
Yes.
absolutely right. So we can actually change this so that if we select this door and then scale it up just a little, just enough for there to be
Off the ground.
off the ground. And now we walk through it, it's just going to go for a lot longer. It eventually, oops, unless I run into it, it eventually slows down because we did put some friction in our hinge so that it wouldn't float forever. But you can already tell that it's rotating a lot longer than it used to.
Got it. So can you select the attachment again for the arrows?
Yeah, of course. So we have the door attachment here.
Yeah. So
And we
the
have
yellow one, right? You said that's the
Yeah.
primary axis.
That's the primary axis.
So if we're talking, these are a hinge constraint, right? And you're mirroring reality. A lot of doors have multiple hinges, like one at the top and one at the bottom, or one at the top, one in the middle, one at the bottom. Is the reason why you only have to put, and this was a question in chat, I saw you chat, is the reason that you only put one attachment at the top is because it will operate on the entirety of that primary axis. So in this case, it's up and down. So you only need to put one.
Exactly. It just I understand why that part could be a little confusing because in real life we do have that second hinge so that it kind of counterbalances the weight of the door kind of hanging on the top hinge.
Yeah.
But the way that our constraint system works is that it's constraining the entire object using as much force and as much torque as it needs so that it can rotate about this axis that we dictated. And so you only need one.
So in theory, then, hypothetically, as long as the primary axis is up and down, could you put it anywhere you want on that pole and the behavior would remain the same?
That's a great question. How about we mess around with it and just find that out together? This one I do know the answer to, but I want to also quiz you. So let's say we move this down. What do you think is going to happen if I just run right now?
In theory, I think it should work exactly the same. But I don't want to mess up my 100% score. I feel like you're tricking me.
Unfortunately, you're partially right.
Uh,
Remember that the objects...
Oh, the magnets are going to be magnets.
The magnets are going to be magnets. And so because we didn't move the attachment of the second door, of the second attachment, it didn't work well.
Oh, shoot. So that means you would have to put both in the middle.
Exactly. So if we
take
take
all right. Okay, that's like half right. That's like half right. Okay.
Yeah. So let's do it. Let's take the first one and the second one, and then just move them down. And now, what do you think is gonna happen?
It'll work exactly the same.
Exactly.
There
we go. That's right. So you weren't completely wrong. So you're at a 4.5 out of 5.
Okay, I'll take it. That's still an A.
Still an A. Exactly. Cool. Okay. Any other questions on the chat? I know this part is probably the most confusing so far,
We're
and I would love to
actually,
clarify anything.
that's very kind. Oh wait, is it Q&A time? Darn it. Okay, I guess it technically, Mod, could you open up Q&A? We'll go a bit over for you, chat. We'll go a bit over. So start filling up the Q&A section. Upvoting questions there. There's a couple more things we want to get through for constraints. But we'll start answering more questions starting now. Mob, do you want to talk about the actuator types?
Yeah.
Like motors and stuff?
Yeah, I'll give a high level overview of how they work, and then we can dive into it in a future session more in depth.
Yeah,
So,
because the question was about a great segue was they're wondering if you wanted it to spin literally like endlessly. Like outside of moving the door up so there's no friction.
Yep, absolutely. So you can, as a teaser, you could also use mover constraints for this. There's a whole tutorial on creating spinning objects that you can go check out where you can see the different tooling. But one of the ways is by using a hinge constraint and just changing its actuator type. So if we have this hinge constraint that's fully set up properly, and we go to its properties here, its actuator type currently is set to none. It's just kind of free floating. And your options are none, motor, and servo. And so if we click motor, we get this new set of properties that we can change. And if we go ahead and change it so that its angular velocity is 10 and its max acceleration, max torque are high enough that it's just good like that, and we run it, we now have it spinning at the angular velocity of 10. It's that simple. So let's see, let's open it up and let's see how that changes with different values. So if we change this to 100, it just starts going at 100. If we change this to 1, it slows it down just like that. So that's one actuator type, which is really fun to play with.
So it's just a motor that literally just keeps moving.
Just around. A motor that what matters is that you have to make sure that you have enough torque. So right now, if I wanted to spin at this rate, but I have 0 torque, it's just not going to spin. Right now it's free floating, but
got it.
As you can see, it just doesn't have enough torque to push it.
Got it. Okay. This is a great segue. A Q&A actually is about one of the next actuator types. It's what if you don't want the door to make a full rotation? What if you want it to just work like a normal door? Like what the suggested question is, would you just use friction for that? If like how do you make it not do a full rotation?
Yeah. Let's talk through two normal doors. So the first door will be, most doors don't open 360 degrees. Yeah. They usually open 90 degrees each way. And so let's go into this hinge constraint and set it back to none so that it's working like a normal door. And then you see right below it has this limits enabled. And this limits enabled is where what the secondary axis starts to matter. So if we pull up the attachments, remember our orange arrow is pointing to the left on both of them right now, right? Mm-hmm. And what I'm actually going to do is rotate these 180 degrees so that it's a little bit more intuitive which way 0 is. Okay. So we're going to take the first attachment and put it to there, and we're going to take the second attachment and put it to there. And so now 0 degrees is pointing exactly towards the door. Okay. And so if we go ahead and change the limits, so we have limits enabled, and it's currently set to -45 to 45, which you can see through these green arrows. So if we wanted to open 90 degrees each way, we're going to do -90 and then +90. And now if we go ahead and see how it behaves, we can see that we run into it and it closes. So if you remember, I'm actually going to fix this. There's quite a bit of friction on this door. Let me scale this up just a tad and then play here.
That's so cool. You literally just have to pick it off the ground. You don't have to go change a setting.
Oh, oh yeah, I did it. Right. Is that?
Oh yeah. Yep,
okay, yeah, we're good. All right, cool. So now we run into it. It stops right there. And if we run into it the other way, it stops right there. And so little quiz time. If I set this motor or this hinge constraint to be a motor, do you think it's going to overcome it? Or what do you think is going to happen?
If you do motor, I think it should respect the initial 90 and just flat back and forth.
Well, actually, the motor only pushes it one way. And so...
that's right. It'll just get stuck.
Exactly. Yeah. So
I'm not getting an 85% now. I'm dropping down to a B. Darn it.
Yeah, exactly. So it spun in the positive direction and now it's locked here. Like I could try to push it this way, but the motor is
But the
going to keep
motor's going to
pushing it.
keep going in the same direction.
Exactly. So that's one normal door, we'll call it, right? We
Mhm.
have a normal door that's set up to be -90 to 90. But another sort of normal door I've seen is a self-closing door. And this is where servo comes in, and it's pretty fun. So we'll leave the limits enabled because that's pretty intuitive. And now what servo does is that it tries to get the door to a specific angle based on what you set it at. And that's this target angle. So this is why I wanted to set both attachments to have their secondary axis towards what I consider to be closed, so that it's a little bit more intuitive when I go to servo, and then I have target angle set to 0. So let's see what happens here. So now remember, I lifted it so that it's off the ground. Ooh, there's a lot of torque here that's pushing against me. But as you can see, it always wants to go back to angle 0.
Oh, got it.
And
So it's
so
like
the
a
way to
self-closing
mess
door.
Exactly. And to avoid so much resistance, you can just decrease the amount of torque that it's pushing on you. So let's close this. And if we make this 100, then we should be able to push this a lot more. Wow, 100 is still a lot too. Oop. Jesus, it's a strong door. How about
Door's jacked.
10? I know, right? I need to get on that routine. All right. All right, there we go.
Okay,
A lot
nice,
easier
nice.
to push. And then when I let it go, it goes back to 0. And I can push it the other way. And remember, the limits are still enabled, so it won't pass this 90 degrees. And then when I let go, it goes back to 0 degrees. And that's the third actuator type. So we had
Nice.
none, which was just a regular kind of rotating door. We have motor, where it's applying a torque to try to get it to move constantly. We have servo, where it's trying to get it to the target angle. And then limits enabled are separate, where it kind of says what the allowed motion is.
Amazing. All right, hey chat, y'all were super patient. We went a little bit into the Q&A time, which means we're gonna go a little bit longer because Q&A is like the whole point of a stream. So don't worry,
Absolutely.
we're not jipping you on your Q&A time. We're here to chat. So that's the end of the structured curriculum. We're Mob is here to answer all the questions, and I'm here to learn alongside with you. So we have a couple questions here.
Okay.
The one with the most upvotes right now is, does this physics engine emulate centripetal force and acceleration?
Does this physics engine emulate centripetal force and acceleration? It does, and I'm trying to see how I can show you. What if we make something that has a rope tied to it and then is spinning really fast? So that should work. Yeah, let's do it. Okay. So we're gonna keep the same door situation, and we're gonna set it to be. We're gonna take off the limits enabled, and then set it to be a motor. And just to make sure, so I'm gonna go a little fast here, but let me know if I'm
totally fine.
confusing. Cool. So that spins fast.
It's motoring.
And then if we go ahead and create a sphere here, and then we're gonna go ahead and constrain that sphere via a rope. So here, and then on the edge of the door. And then its length, let's make it 10. And now run it. Let's see what we get. Oh, you get this funky behavior, but yeah, look, it's slowly gonna go.
Eventually, now we're cooking.
And the reason at first it didn't do this smoothly is because you saw that it wasn't perfectly taut, and so it was actually like counteracting the door when it first swung, like right there at that beginning part.
Because the physics is consistent.
Exactly.
So
but
just
if you
like
saw
it happened in real life,
how quick it took me to build that, like I did that in like 20 seconds. It's
with
just that
not writing
easy.
a single line of code.
Not a single line of code.
Absolutely insane. Absolutely unhinged. Okay, I'm sorry. Next question. 2 thumbs up. If 2 objects are both unanchored with the hinge constraint, which object would move to snap to the other, or would both move? I'm also just going to ping you these so you can read them.
Yeah, that's a great question. I know we have some ordering, and I just don't want to misquote it. So I think attachment 1 usually magnetizes to attachment 0. But this is one of those that I would also recommend just kind of trial and erroring it. So if we get rid of the ball and the rope, and if we take this frame and unanchor it, let's see where these lie. So we're going to move both of these so that it's over one. And then I actually have to make this one scale up. Otherwise, we're going to have some weird stuff. Okay, cool. All right, so we have there, and we have this is the one from the rope. So we have the door attachment, we have the frame attachment, and the frame is right at the edge of this kind of gray block. So let's see what happens. So if we run it, oh, I forgot that it's still set to motor. Let's make sure we turn that off. Otherwise, we're gonna get some funky behavior. And we run it now. Okay, so it looks like they moved towards each other. It literally was similar to a magnet. This one moved over a block, so if we stop it here, it kind of separate out.
Yeah, so it's like, so it meets in the median distance between the two.
Looks like it.
It looks that way.
Honestly, it might be that it's based on the mass of the door. Like if this door
that would
was,
make sense.
Yeah, like let's see if we take this door and scale it. This is the super fun part of Roblox. Let's just, I guess I need to, oh, wait.
Oh, you're still running. Got it.
Yeah. Let's go here.
Giga door.
Okay. Yeah, but the frame is going to be tiny. Let's see. I'm pretty sure the door isn't going to move much. Yeah, it shifted over a tiny bit, but horizontally, the frame is the one that moved.
So the object with more mass is the one that has priority in terms of put it another way, the object with less mass is the one that moves towards the one that has more.
They both move. It's just proportional. So it seems like as you can tell here, the blue door did move a little bit.
It did move, yeah.
Yeah, but it moved a lot less than the frame because it's a lot heftier.
Got it. Well, it is a giga door. That's huge. Okay, all right. I have a question. I'm gonna jump in. If we go back to Gigador, okay, and we turn it into a motor, and we keep the post comically small, would that work? You would just be dependent on having sufficient torque to move Gigador.
Wow, you actually got the exact terminology down. So I am gonna anchor the frame.
Okay.
But let's set this to motor, and then this max torque, if we keep it at like 10, which is really low, I'm pretty sure this won't work because it's too low. Okay, so one, you see the attachments. So let's fix that. Let's stop this. Let's make this door attachment and move it down some. So we're gonna move it down here so that Gigador is actually gonna be in the air.
Okay.
All right.
Nice.
All right, Gigador is in the air. And we do have the hinge constraint set to motor, but it seems like we just don't have enough torque. So let's add maybe like 5 zeros here. Huh.
Still not enough.
Not enough, huh? Let's see.
Door is 2 giga. Oh my god. Oh, there we go.
You know what's fun to mess around with here, actually? So let's go something that's not enough, right? So let's stop this, run it. And we go to the hinge constraint. So this will be actually combining some topics from before. So this one, we added like 3 zeros or 4 zeros and it wasn't enough, right?
Yeah.
But it's probably because it's just too massive. So what if we take this door and change its density? So right now its mass is set to like 7,200. Do you see that?
Yeah, it's huge.
A huge mass. So what if we do like 0.00035? All right, so now it's set to 200. Oh, there it is.
Wow, so it's like cool? Making it out of concrete, and now it's like, made out of foam.
Yeah,
so
exactly.
So large. How interesting.
Yeah, and so it turns out that the lower limit is 0.01, but between that and changing the actual max torque here, we can get different values. So we have there, but we can also set it to rotate really slow.
Wow.
Yeah, so this is combining, the exact torque that you thought of initially, but then you can also think, oh, if I have a lot of torque, then maybe I need to decrease the mass of what I'm spinning. You can go change the density.
Got it. All right. I just one real quick. So for
Okay.
Gigador, there's a really good question here I want to ask.
Okay.
But what if you like for the use case of this? Like, so we're talking about spinning doors and motors, right?
Okay.
What if you like? Could you just make this like an obstacle course in some way? Like we talked about before. Like, what if you like if you wanted to like move through like, because what if your character collided with Gigador, or what if you wanted to try to get through while Gigador was spinning, but there's this
Hmm.
giant, but the door frame's in the way. Could you get all this physics, out of the box, really cool functionality, but in like a more abstract gamified sense? So it's not like obvious it's a door.
Yeah, absolutely. So if I'm understanding you correctly, you kind of want to create an obstacle course where Gigador is the thing you're trying to avoid, and you don't even need to think about the frame,
Yeah,
right?
exactly. Or even not just an obstacle course, but it's like if you have all this really cool interactive physics capabilities, it doesn't have to be like realistic in the sense of like a
Right.
door, but you
Yep.
can you can set up these really cool interactions that are rooted in physics principles.
Hmm. Exactly. So let's test it out. First, let's make sure that all this is moving properly. So I'm going to make this frame attachment move higher here, and then apply enough torque and lower the density of it so that we can make it spin, and then we'll just walk through it. So the density of this is going to be really low. And then if we go to the hinge constraint, we're going to make sure it's motor and it has a lot of torque. And for the sake of this, we're just going to make it like 2. So this ideally should make Gigador spin. All right, awesome. So we have it spinning here. And as it stands today, if we were a character playing around, I would need to avoid not only Gigador, I guess if I lower Gigador, but the frame. And right now we don't want that to be the case, right? And so first off, let's make Gigador. This one, let's move it up and then scale it so that it actually reaches the ground like that. So let me double check that this is working as intended.
Now it's
Awesome,
a
yeah.
menacing Gigador.
Now it's literally going to push me out, right?
Yeah.
And we want to create an obstacle course, but this obstacle course should only be around Gigador and not around this frame here. I'm going to get pushed out.
Yeah.
Anyway, I'm actually going to quiz you because I think that you have enough knowledge to know what to do for part of it. So there's 2 aspects to this frame that we want to ignore. We want the players to not see it,
Mhm.
and we want the players to not be able to collide with it.
Yeah.
So which of these have we already gone through today?
Can collide. So you can just walk right
Exactly.
through the red part,
Exactly.
which you
So we
need
can
in
go.
order for the hinge constraint to work. So it's not
Yep.
like you can just delete it. Like you need the frame in order for, to have anything spin, whether it's something for an obstacle course or something else.
For this implementation, yes,
Yeah.
but there is a tutorial that goes for creating spinning objects that goes through
Oh yeah,
other
Mod, can you link that?
options.
There's more in the rabbit hole.
So we'll turn
Again.
off can collide for this frame, and then the part for not being able to see it is just change its transparency to 100. Oop, that's supposed to be 100, but doesn't make a difference. Cool. So now you don't see it, and you can't collide with it. And if we take this hinge constraint, and we're actually just going to keep it at velocity 0 so that we can actually test it, and we play here, the frame is still there. So the frame is still here.
But you'll be able to walk through it and you don't see it.
I can't see it, and I can walk through it. Whereas if I go to the frame and turn on Can Collide as it was before, then now I can't walk through it.
Got it. So
Yeah.
now, so if you feel like that you're locked into, oh, I have to have these parts or I have to have XYZ in order to get this physics, interaction that I want, you aren't. Like you can make it transparent. You can turn off the collision, and you can get the physics actions without having to have like, the part infrastructure set up for it.
Yeah, exactly. Exactly.
So if you get it moving now, then you literally just
Yeah.
have a giant rotating obstacle.
Yeah, I think right now it's just too heavy for this. Wait, this is the frame. Oops. Door is already set there, so if we stop this and then rerun it. Let's see, hinge constraint set to motor. This one we want to be 5. And then we have the frame set to can collide off and transparent. Let's let's see if this works. Perfect. Now
Nice.
all I'm worrying about is Gigador, but somewhere over here, if I were to get close enough to the frame, I wouldn't be able to run into it.
Which is great. Like, and you look at that, and it's not immediately obvious that there's no scripting involved with this.
Yeah, no scripting whatsoever right now.
But you're like, if you're looking like that could be a giant, fire tower. That could be like anything you could imagine. And
Exactly.
that could be like some like giant water spirit. Like, use your imagination for whatever giant thing you could have twirling around. And
Exactly.
you don't have to code anything.
That's the promise of Roblox. We want you to empower your creativity so that you can think of like, yeah, I want this really fun obstacle course. Let me build it as easily as possible. And, as you pointed out, there is no coding so far. I mean, I haven't touched code a single time in this tutorial.
Crazy. All right, we got questions. We're jumping back in. Up to the top, there was... Hold on. Okay, is momentum a feature? Example, if a smaller sphere collides with a larger sphere, and the smaller is moving and larger is stationary, will there be an impulse on the larger sphere?
100%.
So yes.
Yes, 100%. And that's, if we have an audience asking about momentum, then they would love to go read about the other material properties with elasticity weight and friction weight, because we're kind of applying the same concept of like, in momentum, the object with the higher mass is usually affected less by a collision. Imagine a super heavy ball that's hit by a small ball. The super heavy ball isn't going to move much. And so similarly, they can go mess around and learn about the material properties that are weight related. So here you can see elasticity weight and friction weight. And what these do is that when two objects interact, the actual value that you use for those collisions is weighted proportionally based on these weights. So if you have one object that has elasticity weight of 1, actually, let me see if I can pull it up here. Physical properties. Perfect. Yeah, so it's a little more mathy, but if you understand momentum, then I recommend you go down this rabbit hole of learning how the weighting behavior works for these physical properties.
Amazing. That's so sick. All right, next question.
Next question.
Have, can you create a functioning seesaw? Or in general, when setting a pivot with an object, will there be moments about the pivot depending on the mass on either side?
Can you make a functioning seesaw?
Yeah.
Absolutely. Yeah, just have the seesaw connected to the base with a hinge constraint that's set to none so that it can just freely spin. And then the amount of force that is going to be applied to each side of the seesaw will be based on, how much your character weighs. And you should be able to, like, if you can control the amount of force of up and down the way that you do with your legs in real life, then you can do that in Roblox as well.
Nice.
Does that make sense?
I think so.
I can try to do this, but I don't know how much time we have. It'd actually be a pretty fun challenge. Let's see.
All right, this one should be a pretty quick yes or no. Can you add constraints to humanoids? So if you wanted to make a bungee jumping simulation.
That's a great question. Yes, but at that point you do need to get into coding now, because where you place the attachment, the humanoid isn't live right now in edit mode. And so you'll have to build this constraint with a script once the character is loaded in. And then you can say, like, put the attachment at the left foot, and then put the other attachment of the bungee cord wherever that's supposed to be, attached to the top of a bridge or whatever it is. And then that will work. But because the humanoid isn't created yet, it's not super, super easy.
Got it.
Does that make sense?
Yeah. Cool. Makes sense. All right, so 2 questions left.
Okay.
One was from the very beginning. So we're going back from 4:15 Pacific time anyway. We're going back to wind. The question is, if I wanted to make only a certain place have wind, I'm assuming by place they mean section within their experience, should I make a script that adds velocity for parts that's in that windy area? So basically, they're wondering if they can subdivide the global impact of the
Of
global
the
wind.
wind.
Yeah. So like if they want to have like a little hurricane corner.
Yeah, I love the eager beavers in our audience. So currently, wind is only supported at the global level, but it is on the roadmap to eventually support localized wind so that you can do this tornado corner or a gust of wind when you are in some part of the obstacle course or something like that. But right now, it is just global.
Okay. And last question. With the frictional, okay, I can read, I promise. With the frictional inclined plane, shouldn't the mass of the sphere also affect how fast it accelerates down the ramp because of rotational inertia? I'm confused why different masses had no change.
Sorry, could you repeat that one more time?
With the when you had friction enabled on the ramp and you
Hmm.
had both balls dropping,
Hmm.
shouldn't the density, the mass of the spheres impact how fast they roll down? And they're confused why the different masses had no change on the rate of the spheres rolling down. So the back to friction and aero. Um,
Yeah, that's a great question. Wow, this is literally getting into like college level physics. So the math answer here is that because both spheres were solid, um, meaning one of them wasn't hollow, they have a moment of inertia that is proportional to each other. And so it actually ends up canceling out. Like both spheres are impacted by gravity. And so gravity is pulling them down, making them rotate. But because both have the same dense sphere and not one being hollow and the other one not, they actually just, the math on both sides of the equation of the equal sign, the mass cancels out. I wish I could prove it to you. I mean, I can look it up, but I rather show the proof offline because it's not the easiest to follow.
got it. So
Short answer is because the geometry is the same, which means dense, fully solid sphere. The mass of it actually doesn't matter for rolling down a ramp.
got it. So because the density is the same, the mass doesn't matter.
Because the shape is the
The
same. So
shape is the same.
a
The shape
solid
is the same.
sphere.
Got it.
Yeah, the density was different,
Yeah,
therefore
yeah.
the mass was different. But because the shape was the same, um, you get the same behavior. A fun fact is if you were able to create a shelled ball here, so one that's hollow inside, it would actually have different behavior.
Interesting. All right. Well, there it is. All right. Hey, you got a compliment. You cooked with that question.
That was a great question. Whoever asked that question, fantastic question.
Oh wait, actually, hold on. Yeah, you didn't get a comment. I take it back. Mom, you didn't get. So the person who asked the question.
Yeah, that compliment does not come to me. That is fully for the audience.
All right. All right. Hey, we're over time. We have talked about physics for an hour and 45 minutes, and
Oh,
I think that that's impressive in and of itself. And it was really
man,
fun.
wasn't it super fun?
It's as somebody who's not super well versed in physics, it was really encouraging to me to be able to see how intuitive the physics system in Roblox is, and how it really just encourages you to pick stuff up and play with it. And you can definitely go in the weeds and get really specific with this, and of course break out coding and scripting as well. But that'll be a topic for Physics 102 and beyond.
Yep, exactly. And I think you kind of pointed to the most important part. Like the best way of learning is just to tinker around with it. Here's a seesaw, by the way. Right? It's there's no characters here, but I just put a hinge between the base and the top and anchored the bottom one. And if we were to move this, like it's always gonna kind of tinker around there. It's gonna rotate about that hinge.
So if you were to playtest and jump on it and walk from one side to the other, it would fall.
Great idea. Let's play here. Let's see if I can balance. All right, so if I, ooh, ooh, all right, and then,
Oh, you're not heavy enough. Oh no, you are.
oh yeah, I'm like right at the edge.
Hey.
I wish that was planned. That was actually awesome.
Nice.
Yeah.
All right, chat. Hey, thanks so much. Keep an eye out on Dev Forum and the YouTube channel. Mod, can you also post the YouTube video? We have one that's about making a sliding door using constraints and drag detectors of all things. So more physics video, very similar concept. Whole video is on there on the YouTube channel. When the VOD will be on the YouTube channel as well, but Dev Forum will be the primary place for you to look at future streams here.
Yeah, and if I can add something there,
yeah, of course.
Audience, if you have any requests for what we should do for Physics 102 or 103, please leave them in the comments. And, you know, we haven't fully written out the script yet for the topics that we'll discuss for the next one. And so we'd love to hear what you're interested in.
Absolutely. Always open to feedback and making the content that y'all want to help make the things you see in your head.
Exactly.
All right. We're going to sign off. We don't have a slick outro, but just use your imagination that we